Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test July 2025. In this video, we discuss the solution of a problem from the section Linear Algebra, and the problem is related to the concept of orthonormal basis. And this problem is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 562954106. Further, this question is suitable for all these examinations. Right. The given question is, let C bracket closed interval 0 comma pi be the real vector space of real valued continuous functions on the closed interval 0 to pi. For positive integer Cn, define Fn, f suffix n, belongs to C0 comma pi by Fn of x is equal to sin nx by sin x when x belongs to the open interval 0 to pi. Fnx is equal to n if x is 0. Fnx is minus 1 to the power of n minus 1 multiplied by n if x is equal to pi. Let V be the real subspace of C0 pi spanned by the set consisting of F1, F2 and F3. Consider the inner product on V given by the inner product of F comma G is equal to 2 by pi integral 0 to pi f of x multiplied by g of x multiplied by sine square x with respect to x. Which of the following statements is true? We are given 4 options. Option 1, F4 belongs to V. Option 2, the set consisting of F1, F2, F3 is an orthonormal basis of V. Option 3, the dimension of V is 2. Option 4, the set consisting of F1, F2, F3 is an orthogonal set but not orthonormal. Right. Let's now discuss the solution of the problem in detail. We have C 0 pi, C closed interval 0 comma pi, which denotes the set of all real valued functions defined on the closed interval 0 to pi which are continuous. Right. Now, it is a vector space over R. It's a real vector space. It's a vector space over R. Correct. Now, for n belongs to n, we have Fn belongs to C0 pi defined like this, and this Fn belongs to this. They are all continuous, and people get a doubt that are they continuous at the end points of the interval, namely x is equal to 0, x is equal to pi. They are continuous. If you want, you can check it up, but it is given to be Fn belongs to C0 pi. Therefore, there is no need of, ascertaining ourselves that this function Fnx is continuous at the endpoints. They are, because Fn belongs to C0 pi. They are defined like this. Right. We continue. Right. This is the functions are here. And we are given V is the real subspace of C0 pi. C0 pi is a vector space, real vector space. In that, V is the real subspace spanned by three functions, f1, f2, f3. V is spanned by these. And we have the inner product on V. The inner product of two functions f comma g is equal to 2 by pi integral 0 to pi f of x dx, f of x multiplied by g of x multiplied by sine square x dx. We now check the orthogonality for m not equal to n. So fm, they are the inner product of fm with fn is equal to 2 by pi integral 0 to pi. Fx is sin mx by sin x. Fm, fn sin nx by sin x multiplied by sine square x dx. Sin x in the denominator, sin x, sin square x in the denominator cancels with sin square x in the numerator. So thus we get 2 by pi integral 0 to pi sin mx into sin nx dx. We recall 2 sin a sin b is equal to cos of a minus b minus cos of a plus b. Right. So for sin mx and sin nx we write 1 by 2 of cos of mx minus nx minus cos of mx plus nx. Right, we write. So mx minus nx is written as m minus n multiplied by x. Mx plus nx is written as m plus n multiplied by x. Correct. 2 cancels and you will get is equal to 1 by pi into integrate. Integral of cos m minus 1 x is sin of m minus n x by m minus n minus sin of m plus n of multiplied by x by m plus n to be evaluated between 0 to pi. No worry, m minus n can sit in the denominator because m not equal to n. No problems. No problems. 1 by pi. For the lower limit, sine of 0 is 0. For the upper limit, 1 by pi into sine of m minus n into pi for the upper by m minus n minus sine of m plus n pi by m plus n. M and n are natural numbers. These are multiples of pi. Sine of multiples of pi is 0. So that means to say the inner product of fm with fn is 0 for m not equal to n. So therefore the set f1, f2, f3 is an orthogonal set because they are pairwise orthogonal. f1, f2 are orthogonal, f2, f3 are orthogonal, f1, f3 are orthogonal because fm is orthogonal to fn when m not equal to n. Right. Not only stop f1, f2, f3, it can go on. Even if you put f4 also, it will work. Right. So from this, it follows that the set consisting of f1, f2, f3 is linearly independent. Why? It is an orthogonal set consisting of non-zero orthogonal vectors. Because every set of non-zero orthogonal vectors is linearly independent. And none of these fn is a 0. Therefore, the set consisting of f1, f2, f3 is an orthogonal set of non-zero orthogonal vectors. Therefore, it is linearly independent. And it is linearly independent and V is spanned by f1, f2, f3. Thus, f1, f2, f3 is a basis of V because V is spanned by f1, f2, f3. And the set consisting of f1, f2, f3 is linearly independent. It spans and it is linearly independent, therefore it's a basis. When it's a basis, the dimension of V is the number of elements present in the basis, that will be 3. But look at our option 3. The dimension of V is 2, which is false, which is not true. Therefore, option 3 is not true. Right. We continue in the next slide. Right, that's what we have. That's what we have. Now we will check for normality. To check for normality, the inner product of Fn with itself is 2 by pi integral 0 to pi sin nx by sin x into sin nx by sin x, because Fn only, into sin square x. Sin square x cancels, and it is equal to 2 by pi integral 0 to pi sin square nx dx. That's equal to 1 by pi 2 sin square nx. For that we have written 1 minus cos 2 nx, and integrate. You will get x minus sin 2nx by 2n to be evaluated between 0 to pi. For the upper limit, 1 by pi into pi minus, this is 0, and for the lower limit it is 0 minus 0, that is 1. 1 by pi into multiplied by pi is 1. So each Fn is normal. That means the inner product of that is 1, norm square is 1. So F1, F2, F3 is not only orthogonal set, and each vector, each F1, F2, F3 has the norm 1, therefore it's an orthonormal set. So F1, F2, F3 is a basis of V. Now this F1, F2, F3 is an orthonormal set, therefore it's an orthonormal basis. Therefore F1, F2, F3 is an orthonormal basis of V. Let's look at our option. Option 2 says F1, F2, F3 is an orthonormal basis of V. Therefore option 2 is true. And option 3 says F1, F2, F3 is orthogonal, but it is not orthonormal, which is not true. Option 4 is not true. Right. We are left with option 1. Right, option 1. F4 belongs to V. We have already seen the inner product of Fm with Fn is 0 when m not equal to n. When m not equal to n, they are orthogonal. Therefore, the set consisting of F1, F2, F3, F4 is an orthogonal set. Why? F1 is orthogonal to F2, F1 is orthogonal to F3, F1 is orthogonal to F4, so on and so forth. Right. When it is an orthogonal set and consisting of non-zero orthogonal vectors, it is linearly independent. From this, it follows that the set consisting of F1, F2, F3, F4 is linearly independent because every set of non-zero orthogonal vectors is linearly independent. Assume that F4 belongs to V. We assume that. That means F4 belongs to the linear span of F1, F2, F3 because V is the linear span of F1, F2, F3. So the meaning of this is F4 is a linear combination of F1, F2, F3. When F4 is a linear combination of F1, F2, F3, then the set F1, F2, F3, F4 is linearly dependent, which is a contradiction. Just now we have seen that the set consisting of F1, F2, F3, F4 is linearly independent. A contradiction. This contradiction tells us that our assumption F4 belongs to V is not true. Therefore, F4 doesn't belong to V. Thus, option 1 is not true. Summarizing all the options, the answer to this question is option 2. That is the detailed discussion of the solution of this problem, and it is an interesting problem, right? I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel if you have not already subscribed. Yes. I'm sure we will meet all of you once again in another episode of learning. enjoy learning mathematics. I wish you all the best. Thank you.